Yes, we are live now.
All right, cool. Just give it a second. All right, let's get into it. Good morning, good afternoon, or good evening, everybody. Thanks for joining us today for a really great workshop with Adrian Thompson, DevRel at Phi Labs. Preparing for the Archway Hunt-A-Thon that is underway. We'll be covering kind of an introduction to RUST and CosmWasm for those of you out there that are kind of new to it. But this is your chance to kind of like field out questions and also learn directly from one of the key players in the space, Adrian Thompson. I'll hand it off to you.
Okay, thanks a lot. Hi everyone. So today, hopefully, will be a very useful session for developers taking part in this hackathon. Especially those coming from the Web2 space. I can understand that it might be a bit difficult to wrap your heads around RUST, a new programming language, and also CosmWasm, the smart contract engine that we use on Archway. So this presentation should help you to get started, set up a developer environment, and just go through the basics of RUST and CosmWasm that should help you to build awesome dApps. So let's get started. So a quick overview of what Archway is. So we pride ourselves as being the first value capture engine within the blockchain ecosystem, especially within the Cosmos space. So our chain is built on the Cosmos SDK, which makes it easy for us to build out our protocol, the Archway protocol. And there are a number of different modules that are very useful. And IBC is one of those powerful modules that allows for interoperability across chains. So because of that, right now we have, I think, access to 30 plus chains within the Cosmos ecosystem. And then because of IBC, we're able to also tap into other ecosystems like Solana, Ethereum/EVM, and others are coming on board as well. So for Archway, our smart contract engine is built on CosmWasm, and the language of choice is RUST for writing your smart contracts. We are also working on other languages integrations. So for example, Go, which Cosmos SDK is built on Go. And I think Go is a bit easier to learn than RUST, but RUST is still a very powerful language, and very after you get a hang of it, it implements a lot of features that you think other language should copy. So you'll see from the presentation that some of the stuff might be a bit different than what you're used to from other languages, but trust me when I say that RUST is a very powerful and very useful language. At the core of Archway is our rewards module, and that's why we call ourselves we see ourselves as a value capture engine, because it allows for sharing the value with the dApp developers that bring users to the platform or to the ecosystem. And we are releasing a V7 upgrade soon, I think within next week. But the V7 upgrade has been implemented on our testnet, which is Constantine. And that has 4 additional modules that we hope that developers will take advantage of within this hackathon as well. So that's just a brief overview of Archway. So let's jump into CosmWasm. So as I said before, CosmWasm is a smart contract engine that allows developers to write smart contracts on top of the Archway protocol. It's based on WebAssembly. So when you compile your contracts, it's converted to a WASM file or WASM executable, and that's then deployed to the blockchain for you to then create an instance of your contract that users can interact with. As I said before, IBC is a very powerful protocol built on top of Cosmos SDK, and that we utilize as well. And you can access or tap into IBC via your smart contracts. So your smart contracts can now access other chains outside of Archway, which is a very powerful a solution or use case. It allows for very unique and powerful use cases to create not just apps that are touching the user base within Archway, but also other ecosystems. So as I said, Rust is the primary language used, but we're definitely looking to add additional languages as well. So the first thing we're going to be doing is setting up a dev environment. Two primary IDEs that you'd usually use for building Rust-based applications. I don't remember the name, but this IDE, what's the name? It just slipped me. But they have this Rust Rover IDE solution. Now I think they were using a Java-based solution that has a plugin for Rust, but now they've created their own a standalone solution just for Rust. So you can decide to use that, and you don't need to install any additional plugins or anything. You just install the IDE and you're good to go. But for Visual Studio Code, which I use, you definitely need to install a few plugins. Rust Analyzer is one of the primary plugins if you want to have syntax highlighting, code navigation, and code completion capabilities, and then the code LLDB for debugging. So Visual Studio Code is what I use. So these are the primary dependencies when you're building smart contracts on top of Archway. So you need Rust-C, which is the Rust compiler. I'll share a link to the installation guide on the Archway docs, which will link to the installation installers for all of these applications. So Rust-C, that's a primary thing required for the Rust programming language. That's a compiler use. Cargo is like a package manager similar to NPM or GoGet. And this is what you'd use to install various packages within the Rust ecosystem. Our Cargo Generate is what is used to start a new project from pre-existing code. And when you install, for example, Archway Developer CLI, you will have an option to install a few starter projects, and that uses Cargo Generate to create those projects from templates. So Node.js and NPM are required, and it's mainly required for the use of the Archway Developer CLI. And Archway Developer CLI really is a tool that helps you to build and configure and deploy your contracts and interact with your contracts on-chain. Well, off-chain and on-chain. So for creating new projects, creating accounts, compiling your contracts locally, and then deploying and interacting with your contracts on-chain. So we created that solution. I think it's the best solution to use as opposed to trying to interact or build out anything using our Archway D client. And if you're going to be using Archway Developer CLI, you'd also need Docker, because Docker is required for compiling your contracts, because we use what's called Rust Optimizer. And well, we use a version of Rust Optimizer called the Workspace Optimizer, which is dependent on Docker in order to compile your contracts. And this allows you to have multiple contracts within one project, and then it compiles all those contracts into one. Yeah, so this is the installation guide. Let me see if we can show this quickly. Yeah, so this is Archway docs. So literally you go through, it provides the links to all the various resources that you would need to get all these applications installed. So Rust, Cargo Generate, Node.js, Docker, and Archway Developer CLI. And Archway is also optional if you want to do the low-level stuff. So one thing to note is that it is recommended. So the developer environments that are compatible with this dev setup is Mac OS, Linux, and on Windows you can use WSL or WSL2. Okay, so let's jump into some Rust basics. So yeah, I'm going to jump into the various areas of Rust that I think are required to fully understand in order to just dive deep into Rust. So the first thing is, let's look at variables. So variables are statically typed within Rust, meaning that they are known at compile time as opposed to runtime. And that's very critical to how Rust is set up, in that Rust does a lot of things for you at compile time to prevent you from like writing bad code. And you'll see that going forward, like even when you're writing your code at that time, it does some stuff in the background to really iron out or remove a lot of the issues you might experience when you decide to compile. So you see a lot of errors. So Rust is very good at that. One thing, very important thing to know, is that all variables by default are immutable, and this is totally different from other development languages, programming languages. So when you create a variable, that variable by default is immutable. But you can choose to set it as, or make the variable mutable, but you'd have to declare that. But by default, yeah, you need to remember that all variables are immutable. Another important thing is that Rust enforces a lifetime for each variable, and we'll go through some examples of this. And so this is similar to scoping within other programming languages, but I think Rust carries it to even a different, a deeper level. And yeah, once you understand when a variable dies based on scoping and stuff, it will prevent you from writing bad code. So that's something definitely you need to understand. Also, variable shadowing is possible. Before Rust, I've never seen this particular feature. I've used a number of languages. Maybe it exists in a few other languages, I'm not sure, but I've never used shadowing before, and I'm not sure if it's really good to use shadowing. But there are I think good use cases for utilizing shadowing, but it's good to know that it exists, so that if you see it in any other code, that you can understand how it works. And I think one of the major important components of Rust is understanding that each variable or each value in Rust has an owner, and it can only have one owner at a time. And once you understand that, when you see a lot of errors popping up in your code, you can understand how to try to sort them out, because without understanding this, you might get crazy. So yeah, these are, I think, the main areas that you need to focus on when it comes to variables. So let's dig into some quick examples. So as you see here, by default, without setting the type, Rust infers the type. So if it sees a number, it automatically assigns an I32 to that particular type. For example, if it sees a floating point number, it automatically assigns a F64 type to the value. And if this is a string, it automatically assigns a string slice. So that's inferred variable declaration. But I think it's best to always explicitly define your variables, and you do that by adding a colon and then the type to the variable. So similar as above, but you're explicitly setting the type to an I32 and so on and so forth. Yep. So as I said before, all variables by default are immutable. So using the let keyword in order to create a variable, let immutable variable equal 10. So by default, you can't change the value of immutable var. So if you try to do that, your Rust compiler will complain and throw an error. But if you want to create a mutable variable, all you need to do is add the mod keyword before the variable name, and then you can then go about changing the variable, which is done down here, and you won't have a problem. So it's very simple. It's just that you need to remember that you need to do that. Okay, so lifetime, as I said before in Rust, you have to be very cognizant of lifetime and scoping. So let's look at this example. So we've created a variable R, and then we've created a scope here. So this is a code segment that's separate from the rest of the code. So then we've created a new variable X, assigned it 5. Then we've assigned a value or a reference to the value X for R. We're able to print R and get the value 5 here. So this works as designed. But if you then try to print the variable R outside of the scope, you will get an error because this value X was created within the scope here, and it doesn't. So the lifetime of X ends right here. And because of this, if you try to use R, which is dependent on the reference to X, you'll get an error. So things like that you just need to understand when it comes to understanding the scoping or lifetime within Rust. So variable shadowing. So this example, let's go through it quickly. So we've assigned a value of 5 to X. We're able to print X. X is 5. Then we recreated the variable X and assign the value as X plus 1. So 5 plus 1. So if we try to print X now, it's printing the shadow, this new variable that is now shadowing the original variable. And one thing to note with shadowing, you can actually change the variable type when you're shadowing a variable. So if X equals 5 here, and you wanted to change X into a string, for example, it's allowed. But then we go into a scope here. We are shadowing X again. So we're creating X as assigning 0 to X. And if we print it here, it prints out 0. But now if you try to print X here, because as we said, lifetime, the lifetime of this shadow ends here. Oh, what happened there? Okay, sorry about that. Yeah. So the lifetime of this shadow of X ends here, and therefore the value printed would be the last shadow created, which is X plus 1, which is 6. So this initial creation of X or assignment of X is no longer being used, and it at the end of this, all these variables will die. So, but just understand that because this shadow of X was created, it lives on until if it was in a different scope, until that scope ends or the main scope ends. So that's something to note about shadowing. Ownership. So ownership was a big thing for me to grasp initially when I started writing code in Rust. So these are the main rules you need to understand when it comes to ownership. So each value in Rust has an owner. So X equals 5, that value, owner, X is the owner of that value. If you change or assign X to another variable, that variable now owns the value 5. So that's only one owner at a time. So there can only be one owner at a time. And when the owner goes out of scope, the value will be destroyed. So that's, you need to be careful of that as well. So if I have string 1 here, string 2, and then I tried, and then string 2 is assigned string 1, and then I tried to access, or if this was in a function, the value of string 1 would be destroyed when string 2 dies, and so string 1 won't have a value. But let's look at this quick example. So if string 1 equals do not move me, let string 2 equals string 1. So now this value do not move me has moved from string 1 to string 2. So if you try to print string 1, you'll get this message within the compiler saying that borrow or move value string one. So string one doesn't have a value anymore, or it has been moved. And the thing I like about Rust or its compiler is that it's smart enough to let you know that because you move the value from string one to string two, you can't access it anymore. So it gives you this error, a borrowed of move value string one. So what the general solution here, if cloning is enabled for this particular variable type or type, is to just clone the value. So it creates a copy. So this is one particular solution. Another solution would be, let's go through this example so we can explain what that solution would be. So if we have a function call, so if we have string one, do not move me to string, we assign the string to string two, then we call this function print string two. If we try to print string one again, it will fail because when string two, because the value is copied from string one to string two and passed into the function, when this function ends here, the value that was passed into string two is destroyed. So it doesn't go back to string one. So after the function completes and then you try to print string one, you see that it fails because the borrowed value no longer exists within string one. And another solution, so you can either clone, which is copy the value, or you can use a reference. So in this example, you simply pass string one as a reference. So this should be str1 as a reference. So it's picking up a reference, not picking up the exact value. And you can then print the reference to that value. So you print out the exact value, but you don't have control, or you've not taken ownership of the value that was owned by string one. You just have a reference to that value. And then now string one has, because it still has the ownership of the value, do not move me, you're able to print the string one variable. So this borrowing concept is very important to understand within Rust. Another area within Rust I think that's extremely important to understand is options, result, and match. And match is like a switch in other languages. But let's go through options. So options represents the possibility of absence. So what in other languages you might use null, you can't do that within Rust. So you definitely, if there is a possibility that there won't be a value, options is the way to go in Rust. So you can have some value if there is a value, or none if there is no value. So none in a sense could be like null, but the options in itself is a enum type. So it's built into Rust, and there are two possible values, some or none. So let's look at an example here. Let's create this variable some number. You assign some value. So for this particular variable, you would need to actually use the words, use this sum value, because it was assigned as an option, but because it still works. But let's say if you create a variable no number and you assign this, it's an I32, but you've assigned it that there's an option. It's an option. So you've created it's an enum. It's using the option type, and within that type, it's taking the I32 type. So in essence, it's an I32. But now you can set this value to either none or some value of I32. So, all right, for this example, the default value is set to none. So currently, there's no value set within this no number. But if we decided to, so that doesn't have the mutable keyboard, so you can't change the value, so that will stay as none forever. But say it will only be useful if you have the mutable keyword there, because if you want to be able to change the value from none to a some value, then you need to do that. So other number is set as well as an optional I32. By default, it's set to none, but then we come down here and whatever logic is executed, we now want to set the value of other number to 55, and then you'll use sum 55. So you're assigning a value. Initially, the value is set to none, which in other language might be referenced as null, even though that doesn't exist in terms of the concept, but it's just that once you see none, you know that there's no value there. But then when you want to assign a particular value, which is, it must be of the I32 type, then you can come in now and say, all right, some value, add the value. If you assign a type, a value that's not I32, you get an error. All right, the other type that is very important to understand is the result type. And this is usually used when we're dealing with error handling. So if you have a function and you want to either say that, hey, the function returns a success, you'd use OK value. But if it returns an error, it uses this error handler and assign that particular error. So with the result, it's like a tuple with two values. So you either have OK or error. So this allows for error handling. So let's look at this example. So for example, if we're trying to load a file, for example, so we're trying to read a file. So we have this file example.txt. We pass this file to this function read file contents, and here we see that we're opening the file. And one important thing with Rust is that you can use this shorthand notation with the question sign to throw an error if an error occurs. So if you try to open, when this function is called, if it tries to open the file and it's not able to open the file, not able to find the file or open the file for whatever reason, and it generates an error, or because of this question sign, it will automatically throw an error. It will stop execution and return an error. So if you see this result here, string, this will be none, but and then this IO error will be returned. So yeah, that's how it works. So this is the general makeup of most functions within Rust. You either return a success or an error, and the result type is mainly used for this. In CosmWasm, there is a few other types that builds on top of the result type. I think std result, and there might be others. But once you understand how this works, it will be similar for those other types. And yeah, so lastly, match is really essential in terms of because, for example, if you saw options, you can have one of two values. Result, you can have one of two values, but it's not restricted. Like a tuple type in Rust can have any number of values within a tuple. So maybe I should have added tuple as a variable type here as well to just explain what tuples are. But tuples is like having more than one type within a variable. And if you want to know which type currently exists within that variable, the primary way to do that is via the match structure. So this is very similar to switch in a lot of other languages. So this is it. Simply you match some number. For example, here in this example, some number is 42. If the value exists, it will come here, because there is a value 42, so it will print there is a number 42. If this was set to none, then it will come here and print there's no number, as you show in this example with the no number, match no number. It will jump here because there's no value. All right, so let's jump into smart contracts, because I think once you understand those core ideas within Rust, you should be able to start building out basic smart contracts that you can then execute on chain. All right, so the typical contract lifecycle includes just writing your code, building and compiling your code, then storing that compiled version of your code on chain. And once you store your WASM file or executable on chain, you need to instantiate a version of the. Hold on a second. Yeah, you need to instantiate a version of that contract, which will include the contract address. So the same code base can be used to instantiate any number of contracts. So they will have the same contract core, but an instance of that stored compiled executable is what users will interact with. So once you have that instance of your smart contract, then you're able to now execute the various functions or endpoints within that contract. So whether it's a transaction or a query, and that's basically it in terms of the contract lifecycle. So let's go ahead and create a basic project. With this, you definitely need to have Archway CLI installed. So let me go back. Archway developer CLI. So you need to go the installation guide and make sure you have all the dependencies installed, and have Archway developer CLI specially installed, because that's what I'm going to be using to build out a contract quickly. So firstly, what I'm going to be doing is to create a new account, and then that account, once you have a new account, you then request testnet tokens via our faucet on Discord. Right? If that's not working, you can reach out to anyone from the Phylabs team or Archway Foundation team on Discord, and they should be able to help you to get some testnet tokens. And once your account has a testnet token, then as testnet tokens, you can go ahead and create your project. Even though I think the tokens are really necessary when you're starting, when you want to interact with the chain itself. So it's not, creating the project is not really dependent on you having the tokens, but it's based on what we're going to be doing in terms of deploying the contract and stuff. You definitely need those tokens in your account. So then we'll create a new project, and then we'll configure the project. So let me quickly do that. It's new test one. Oh. Okay, so when you get your test account, when you create your test account, you'll see this recovery phrase. This you definitely need to back up and keep safe. You can import it into your Kepler wallet or Leap wallet, as this is required. This is your recovery phrase. So this is what you need to keep this secure and not share it with anyone. I'm not going to be using this account, so I can share it here. But once you have that account, then we would usually go to the faucet. So this is your Archway address. We go to the faucet, enter your Archway address, and within a few seconds, you should see that the account was topped up with at least a few tokens. You can check min scan. And you see that was done. So I have 5 tokens there. All right, so let's create a project. So using Archway developer CLI, all you need to do is Archway new project 1. And the first thing that you need to do is to select a chain. So here this Archway is the production network. Archway testnet is our Constantine testnet. So I'm selecting testnet. First, we need to give a name to the contract. So let's call it increment, because we're going to be using the increment contract. And then you can choose from a template. So these are the 4 templates you can choose from currently. More will be added soon. I think you should be able, I think we'll add where you can start with a blank state, but currently you need to select a template. So let's select the increment template. And it does a lot of things in the background there, but then it asks whether you need the full version to be generated or a minimal version. Let's go with the full version for this example. So this is creating the project, pulling out everything from the Git repo, and like getting all the dependencies for us installed. So after this, I'll just quickly go through the various there seems to be an error with okay, I should have another project. Let me try one of the other templates. Okay, there seems to be an issue there. All right, let me simply use a project that I know is built on the increment contract. All right, so this is a version of the same increment contract. This contract is called increments 2. All right, so let's go through the structure of a contract. So when you use Archway, there are a number of files that are created. The cargo toml file is like this is a general configuration file for the RUST or CosmWasm or RUST project. And this, because we're using workspace, the workspace optimizer, all contracts that come under contracts, the contracts folder, which is here, when you compile, you'll all be compiled together. So all your contracts are here, and each contract will have its own cargo toml file, which is a configuration file for that particular contract. And you can go through and see the various settings. These are the dependencies. For example, Archway bindings are set of bindings that are used to connect to the various Archway features, like the rewards module. I might see this for the other 4 modules as well, although you can still use the Stargate messages, but the bindings makes it a lot easier for you to interact with the core Archway modules or custom modules. And you'll see these other modules that are really used by every single CosmWasm contract. This STD library, the storage library is used to enable a lot of storage features, as well as the CW store. CW2 is for, I think, what is CW2? Not sure, But yeah, these are the primary dependencies within the increment contract that we create. This particular optimization command is what the optimizer or the web optimizer will use. And then you have some other settings that you don't really need to know much about, because once you create a contract, all of this is set for you. For the actual contract, you'll need to go to the source folder, and this state file is what creates your data store. So for this particular contract, the only thing that we're storing really is the state, what is called a state type, which has the count and the owner. So it wants, what we want to know which contract owns this particular value, and then we can increment the count, or well, there's no decrement function, there's only an increment function. So once you execute that increment endpoint, then the count will go up. So by default, you can set the count when you instantiate a contract. You'll see that later. But if it starts at 0 and you increment once, this count will go up. And so generally, this state.rs file is used as a data store. So you put all the values that you'd use to store, you want to store the data on chain for this particular contract in this file. Messages, this is where you would add the various messages that users can execute. So for example, with via execute message, all these are transaction related messages. So right now you can only increment and reset the count. So increment will increase the count by 1, reset will reset to 0, reset the count to 0. These messages here are query related messages. And the only query right now within this particular contract is the get count query, which you simply return the count based on this value here that's stored here. Errors is a neat way of storing various error messages that can be reused throughout your contract. So usually you'd come here, add the various errors, and then you reuse them in your contract. But the meat of the contract is within the contract.rs file. And this particular contract is not that long, but the first interaction within any contract is the instantiate entry point. And entry points are a means of external forces tapping into the contract. So these are functions that users can tap into. So whether it's a transaction or a query. So an instantiate transaction is the first transaction to create an instance of the contract. So essentially what happens for this particular contract is that you create that state variable or state object, and you assign values to it. So there are two values, count. So we set in count to whichever count value that has been sent by the user. So if you look at this instantiate message, the only value that you can submit when you're instantiating this particular contract is this count variable. So if you decide not to set it, I think it defaults to, it doesn't default to anything. So you need to set a value. So that value is required. So this is not optional. If it was optional, then it would be, you could set none. Or if you set an empty value, it will convert that to none. But yeah, so you're setting this count value to message count, which is submitted by the user interacting with the contract or executing this instantiate action or transaction. And then we get the address of the sender and assign it as the owner. So within this info variable comes a lot of different data. So one of that is the sender. And then, as you said, with the clone, because if you decide to not use the clone here, then it will change the owner from info sender to this owner variable. And then if you try to use this variable down below again, you won't be able to. So yeah, simply clone the value for this particular use case. And then for one good thing about CosmWasm by default is that it is upgradable. Contracts by default are upgradable. You can set it to not be upgradable, but by default, it's upgradable. And then because of that, you can set a contract version. So if you're upgrading the contract, then later on you can upgrade, you can increment the contract version number to now have a new version of this contract. Going deeper, after you've instantiated the contract and set the default state, then now you can now interact with the various functions within the contract. And that's through this execute entry point. And an entry point is defined by this particular configuration here. So this execute entry point allows you now to execute an increment and reset. And that comes through the messages. So this execute message, you have increment and result and reset. That's sent here as the message. And then now, as I said before, match is one of the most used component or feature within RUST. We need to know which message was sent. If the increment message was sent, then we execute this increment function here. And all this increment function does is use the state object that was set here and allows us to update the value. And this state object simply has this one struct, and this struct includes account and owner. And the only thing that we're doing here is simply incrementing the state count by 1. And then we're returning OK. So within this result, as I said, you can either return an OK message or an error message. In this case, once this goes through properly, then we just return an OK message, and that's done. And then, yeah, the same for reset. All we're doing here, we're doing an additional check, making sure that the person executing the transaction is actually the owner of the state value, or in this case, the contract. And if not, then we return an error, which is in the errors.rs file. And all this error says is that you're unauthorized. All right. So yeah, so once you are the actual owner, or your address was used to create or instantiate the contract, then we can reset the value to whichever value that was sent as well. And going down to queries. So query is another entry point here, and it's the same thing. There's a query message, and within that message, you have different messages that you can actually execute. There's only one query message here, and that's get count. And all it does, once this message is called, then this doesn't call a separate function. It simply returns the count. So yeah, that's basically it there for the contract. So let's go through and do a quick compile and deployment and see how this works. So as I said, once contracts, after you've created your contract, all you need to do is to compile the contract. So the command to do that within Archway Developer CLI is Archway build, and then the contract name increment 2. Well, let me see. Oh, contracts. And what this does, it goes through if there are any number. You can actually compile or build one contract at a time, but It's also possible by adding, so I did that by adding the name of the contract, but without the name, it will build every single contract that you have listed here. Let me see if there's an issue with my Archway developer CLI build. Try to install the update. Or it could be that there's an error within the contract. Features, libs. Unknown feature std SIMD. Let me try again. Yeah, there's a particular error. So, all right, due to the limitation of time, let me just go through the slides itself then. All right, so for compiling the contract, you need to have RUST, Docker. So Docker needs to be enabled. And all you need to execute is the compile is Archway contracts build. If you want to compile a particular contract, you enter the contract name as well. For deploying a contract for our testnet, you definitely need to have the const token, which is our for Constantine testnet. And for mainnet, you need to have Arch token to pay the transaction fees. And what you need to do is to execute the following command: Archway contract store the contract name, and then and the name of your account that you created, which would have the tokens. Then the next step would be to instantiate the contract, and the instantiation process is very simple. You would execute this particular command for this part. So for the increment contract, it would be Archway contracts, instantiate, and then the name of the contract. So for my particular contract just now, it's increment 2, and that contract takes one argument. So your contract could take a number of arguments. So you need to populate them here as a JSON string. For this particular contract, it takes one argument count, and the value is an I32. So you need to you would submit it as a string. You submit it as an integer, and then once you submit that, it will instantiate a version of the contract, and then we just spit out the contract address. Then all you need to do is to start executing transactions. For example, if you wanted to increment the contract, you'd put Archway contracts execute. So the execute subcommand of the contracts command, and then you'd enter the name of the contract. In my case, it will be increment 2. And then if that command if that entry point takes arguments, then you list them here. And the only thing that this does is to execute the increment entry point. I think this is wrong because this doesn't take any Yeah, so for this, this increment entry point wouldn't take any arguments. So let's look back at the code. Yeah, so the increment entry point doesn't take any arguments. It's, yeah, no arguments. The count, the reset would take an argument. So that in that case, you'd enter a validator. So that's wrong. And then for executing queries, it would be something similar. Archway contracts, and the subcommand would be query. Then you'd need to do another subcommand with smart, and then the contract name, which is increment, and then the get count command, or the get count entry point. I think that's what was going on here then. So the contract is increment and arguments. So you have the increment entry point, and then it has no arguments. Okay, so that's it. And here you have the get count entry point, query entry point, and it doesn't take any arguments, but it will return the value. All right, so that's it. I would have wished I was able to like go through the process of showing you how to compile, build the contract, then go through the deployment stage, and then doing the increment and stuff. But there are some issues here, and it would have taken me some time to figure it out. So because we just have 1 minute remaining, so yeah. But I'm hopeful that you guys like got a good idea of what it takes to really get up and running with building on top of Archway, and fully understanding the core components of Rust that you definitely need to fully understand, and also the core components of CosmWasm, and yeah, getting at least a basic contract deployed on chain that you can interact with. All right, so definitely view the docs. So if you go to docs.archway.io, you'd select the dApp developers section, and there are a number of guides. So I recommend going through the installation, the ID setup, and the setup guide. Understanding gas is good to understand as well, especially if you're building in a front-end system, to understand what is required, especially using some of our tools like the Arch3.js library. And for this particular guide with setting up a basic dApp, you can find it on the guides, My First dApp, and to walk you through everything that I was going through here just now. So like creating the project setup, accessing, getting testnet tokens, producing the executables, deploying your contract on chain, goes through the various commands that you need to execute, instantiating the contract as well, configuring your deployed contract, setting stuff as like your contract premium, which is from our rewards module. So if you want to charge a fee or charge an additional premium or earn in terms of from our rewards module, you'd need to go through this process of setting up the contract metadata. And then after setting up the contract metadata, you can set up the additional premium, and you can start earning from it, all interactions with your contract. And then this goes through interacting with your contract, executing various queries via the command line, executing transactions via the command line. Sorry. And then the final step is building a basic front-end dApp and what is required, and integrating that with Kepler, so you can actually see what's going on. So for this particular example, querying the contract and displaying that on your front end, in your browser, and executing an increment counter, an increment request or transaction, and seeing that played out within your browser. So yeah, there are various dApp examples that you can pull from to get up and running quickly. But yeah, I'm hoping that that was useful, and you can definitely reach out to me if you have any issues on Discord. So Adrian, I think Emperor JM on Discord, and also you can reach out to me, Doors JM on Telegram within our Archway Builders crew. And this Archway Builders crew is available within the DoraHacks main page. If you come here, you'll see it here. So you can get to that Archway Builders Telegram chat here. All right. Thank you very much. That's it from me.
All right. I think that was really awesome. I don't see any questions coming through on our feed, so you must have done a pretty banging job of running through the basics of Rust. But yeah, thank you everybody for attending this. Do check out everything that Adrian just mentioned, including all the links to the hackathon, but also like join the Discord and get engaged. If you have some questions, I'm sure Adrian and the team would be happy to walk you through things and also answer questions outside of the docs. So Adrian, thank you so much for informing the community of this. Really looking forward to all the cool stuff that's going to be coming out of this, man.
Yeah, thanks a lot for having me. Yeah, I'm looking forward to the other workshops as well. We should have a number of workshops from the various teams that have tracks within the hackathon as well. So look out for those as well.
Awesome. Great way to start out. All right, everybody, have a wonderful day and take care, everybody. Thanks for tuning in.